I was afraid it counts down, you know, what the minute I have. First of all, I have to say thank you to the organizing committee. To invite me here is an honor and a pleasure. Pleasure to be in this place and honor to be a guest of honor of the Hungarian Society. That is one of the most important in the world, I have to say. I always follow the work you do here in Hungary. I just put as a first slide, nothing to do with my scientific presentation, the HUPHAR, just because maybe some of you don't know, but is the International Union of Pharmacology and Clinical Pharmacology, and it covers all these countries in green, and it was established in 1965, so after, I think, if I'm good in the history, after the Hungarian Society. I don't go into details because otherwise I will miss time from science, but I would like to advertise our next global meeting that will be held in Melbourne, Australia, and is every 4 years, so it is hard to get to Australia, especially from Europe, but please try to come. It will be an exciting program covering many, many issues of pharmacology. Now to science, yes. Even though I put as a title, Novel Immunopharmacological Drugs for the Treatment of Allergic Diseases, Where Are We? You will see that I focus on what I think is the center of the universe, at least of my scientific universe, and at least talking about innate immune system. And allergy, actually, it is a fruit of a friendship between the innate immune system through the muscle and adaptive immune system because you have IgE. Nevertheless, even if I have as the center of the universe, I don't see now my pointer. I don't know what happened. I have also, I put also the eosinophil as hurt, so quite important, yes. And Venus, because it's a little bit unknown, the basophils. Also, I've been the past president of the European Network for Muscle and Basophil Society, so I don't forget. Now, I have to introduce a little bit the muscle, I think, because I'm not sure how much you know about, but I will be short, otherwise I don't get to the results. So mast cells are mostly known for the pathology and not for the physiology, I'm sure. Everybody here knows, even my neighbor who works in jewelry, she knows about histamine and about muscles. However, besides being bad guys in allergic inflammation, and you will see I will try to ruin your concept of bad guys of muscles, they are also good guys in wound healing. And indeed, I think I remember from when I was a child, I was skating a lot, and I was falling down a lot, and I have a lot of crust in my knees, and at a given time it was itchy, histamine there, muscles there, okay? And they are also irritants, they inactivate irritants, venom, and toxin. They participate in immune responses against elements, parasites, so they have, of course, physiological function. What I say to my students, you are not my student, but I always say, could you imagine we are built with some cells that are only bad for us or are bad for us? Not at all. You should be built with good cells. So to name a muscles the bad ones irritates me in a way, and you will see again that I will try to destroy this concept of bad guys, also in disease, allergic inflammation, because I will also give some novel slide on resolution of inflammation and muscles. Okay, so here, anyway, we start with the bed. You have the spectrum of muscle diseases, and we summarize it in a recent review with my German Charité colleagues. And you have muscle-dependent diseases that, of course, if you don't have muscles, there is no disease, and they put allergic conditions. It can be asthma, Th2 asthma, atopic dermatitis. You have mastocytosis, that is a cancer of muscles, but you have also a lot of muscle-associated diseases, so diseases in which muscle play a role but don't drive the pathogenesis, such as osteoarthritis, for example, interstitial cystitis, and ALS. This is how we view, and I didn't change, I think, for the last at least 15 years this slide, the allergic inflammatory reaction, in which you have the muscles starting all, muscles in atopic individuals by Th2 mechanism are sensitized by IgE specific for the allergen. They are activated by the binding of the allergen to the IgE that are bound to Fc epsilon receptor, and they degranulate and they give, they cause the onset of the acute early phase of allergy. There can be, again, bronchoconstriction if we talk about the lungs, but can be also itching and flare in atopic dermatitis or running nose in allergic rhinitis. So you can understand already from that muscles are everywhere in the body. You cannot understand, so I tell you, they are even in the brain, okay? So, by releasing their mediators, you will be fast in next slide, they also call inflammatory cells to the tissue where they degranulated and release the various mediators, and most prominent is eosinophils. And we defined, as Peter said right now, the allergic effector unit, that is the unit between muscle and eosinophil, and what they are doing, we'll tell you later. This is a late phase of allergy. And if it doesn't finish here and the allergen is still around and you have such a chronic inflammation or such inflammation that cannot be stopped by remission at least or resolution, it can go to a chronic allergy, in which most prominently in any allergy, I have to say, you have disruption of epithelial tissues. And in this disruption, what is typical of allergy, that you have infiltration of bacterial, viruses, and fungi. So this allergic inflammation is very much complicated by these invasors appearing in the tissue, and not only hitting the muscles, eosinophils, the basophils, but also the structural cells. And therefore, there is a going very complicated response. But what has been, I wrote my research goal, but always together with students and collaborators, has long been to determine new immunopharmacology targets, principally on muscles, the primum movens of allergy, and on eosinophils, because eosinophils in allergy always accompany the muscles, and not only in allergy. So if you are interested in other diseases in which they are muscle dependent or muscles have a role in that, look over for the eosinophils too. And we focus on allergic effector unit. Here you have some of the allergy you might have, and please, as pharmacologists and as professor of students, remember the allergy to drugs. Very important issue. Okay, now we don't go through this slide. However, it's important for me to remind you who discovered the muscles, Paul Ehrlich, and he discovered more than 150 years ago by staining them with a metachromatic dye. And here we have electron microscopy, but both by the histochemical staining and the electron microscopy, you can see what a hand grenade, this muscle, look like. You don't have any other cells in the body, plenty of granules. And the granules are plenty of preformed mediators, histamine, as I say, my neighbor knows because of antihistamines, but we have specific neutral proteases such as tryptase. In kinase, you have a preformed cytokine TNF-alpha. We have here an expert, Professor Page, who is an expert on the proteoglycans of muscle. We have heparin, a lot of heparin, I can tell you, preformed, and when they're activated by IgE especially, they release a preformed mediator, but they also synthesize newly formed ones, arachidonic acid metabolites such as prostaglandin D2, LTC4, and they start the synthesis of several chemokines and cytokines, and both the arachidonic acid metabolites and some of these chemokines are attracting the eosinophils and also other immune cells, giving rise, as I said, to the late phase. I'm showing all that because I think that you must come out from here being convinced that it is the best to hit the muscles for allergic therapy rather than other cells. Besides that, muscles, I want also to notice, are long-lived cells. Nobody really did a study how long they can live, but we did some in vitro study many years ago, and we saw that not only they live very long, weeks, years even. I didn't tell the patient to carry out the experiment for years, but I guess so from a previous study of Padaware before I was born in the 50s or 60s, I don't know. And they regenerate their release mediators, and they can be activated multiple times. Now, about the receptors, I mentioned the FcεR1 because it's the Ig receptor, is the most prominent for allergy. However, another very important receptor is the c-KIT, the receptor for stem cell factors, that is a differentiation factor, survival factor for muscles. And I also would like to mention what I call the X2, because it's too long, the name, that has been found only a few years ago, and is a very interesting one because it is specific for muscles, and it binds positively charged substances. So for the one who are in neuro, like substance P, like neurotensin, but for all the one who are in pharmacology, positively charged drugs, such as codeine, such as morphine, such as deserofamine. And so they explain that even non-allergic patients can have a reaction similar to allergy because of direct activation of this X2 receptor. Besides that, you have a lot of other receptors for chemokines, for cytokines, TLRs, you have for complement. So you can imagine by the receptors that I mentioned to you the potency of these cells. Potency participate in various processes depending where they are, depending which receptor finds the ligands and so on. In red, I also circle the receptors that are intriguing me lately, as are the inhibitor receptor, because what I told you are all activating. They activate the muscle, but muscles like NK cells, like T cells, have receptors that want to slow down their activation. And we will talk about the one we defined, CD300A, we define others, and also we have the cannabinoid receptor, but I will bring you to some of them. Now, I don't go to explain too much about eosinophils, the companion of muscle. In a way, they resemble muscle is that they have granules, they are granulocyte, but they don't reside in tissue as a muscle, they reside mostly in the blood. In some tissue, actually, they do. It's something new that has been pointed out, so they also have physiological functions. The granules contain very basic mediators, and you can understand from the name. Major basic protein of eosinophil, eosinophil cationic protein. So you can see from this nomenclature, maybe it's also physiological function, but in allergies they destroy your epithelium to make it easier to understand. Also, they have several receptors. They don't have a specific one for allergy that muscle have, and they share with muscles some of the inhibitory receptors. So, in my view, if you cannot stop the muscles totally, you can also stop the eosinophils. Now, this is an important slide, but I don't oblige you to go through. What we have for allergy, if the patient is mild, moderate, doesn't matter now what is the allergic diseases he suffers of, you have all the strategies, and nobody have said are wrong, are not doing what we want to do. So, for example, in asthma, you have anticholinergic, beta-2 agonist. For all the disease, you have antihistamines, not so much in asthma. You have muscle stabilizing drugs like Cromons, if you still believe in them. I do. And you have the best anti-inflammatory drugs we ever have had, the glucocorticosteroids. However, in the last few years, starting with, I think, 15 years ago, because of the technology of monoclonal antibodies, and because not all the patients do react to what we have, started a new trend to have antibodies against IgE. We thought, wow, allergy is finished. My mom even said, why you are studying allergy instead of cancer? You can go home now. However, not all the patients are really treated by anti-IgE. So there are drugs, antibodies that target cytokine chemokines involved in, especially in eosinophil maturation and infiltration, but also now lately in muscles such as anti-KIT antibodies. You can understand that you don't have KIT, muscle can't survive, for example. It is still under studies, this antibody, and you have also small molecules such as JAK inhibitors and also Bruton kinase inhibitors. But some of them are inefficient, some of them have too much side effects. You might expect JAK inhibitors, even if it's JAK specific, 1, 2, 3, only one, is not specific. So expect side effects. You can say, well, we have also side effects from the glucocorticosteroid. Yes, we do, but as I showed to you, allergy is a complex phenomenon involving other cells that are stopped by the glucocorticosteroid. So our contribution, it has been in the world of the muscle, as I say, mostly the muscles, and we are researching and trying to develop two strategies. One is antagonist of muscle activation, where we try to find out more about these molecules, these receptors, CD48, and one in the world of muscle silencing by anti-CD300A agonistic antibody to try to activate inhibition of the muscles. And here, I don't know if you will have my slides, but I am happy to share them with you. You have again in the review a summary of what I'm showing. Allergic effector units is friendship between muscle and eosinophil that are the main players of allergy. They are indeed, these are the result of years of 10 years of our works. in which we found a soluble interaction between mast cell and eosinophil, some of them specific. For example, eosinophil we found have a stem cell factor, and they activate c-KIT on the mast cell, causing their survival. On the other hand, mast cell release tryptase, a neutral protease that activates PAR2 receptor, protease activator receptor on eosinophil to release IL-8, IL-6. We study, of course, the signal transduction, and this is very special for this interaction and others that I circled here. But what hit our imagination has been the physical interactions that first we detected in tissues. Why we detected in tissue? Because we look for, because everybody knew, I think, that mast cells are kissing the eosinophil. It was not a secret liaison, but if you are minded for something, sometimes you don't see other. And we saw many of these, you see, interactions in the tissue of allergic rhinitis, in asthma, and so on. And therefore, okay, because of this interaction that I didn't really show you before, the physical and the soluble one, especially the physical, is activating CD48 and CD244, also called 2B4, but we found also at the same time, I forgot something important to say, the inhibitor receptor on both the cells, okay? So we draw the conclusion that the allergic effector unit and mast cell and eosinophil interaction are really ugly because they cause even more troubles in allergy. However, since I am in some aspect of my life optimistic, I say it cannot be. Again, thinking that mast cell and eosinophil are not there to cause only damage. It couldn't be. I couldn't believe that. So, no, this is just a slide to remind you that we are doing a very good collaboration as a Charité Berlin, the Institute of Allergy, where they are studying, luckily, I'm not alone, the allergic effector unit and still the soluble interaction by using human skin muscles. They are dermatologists, so are very interested in chronic urticaria, atopic dermatitis, and they reconfirm what we found on human cord blood-derived muscles, where we derive from progenitors, similar stories, and they are working on the main role of GM-CSF, and not of IL-3 and not of IL-5. IL-5 is the main cytokine, survival cytokine, that is targeted by pharmaceutical company as an anti-eosinophil. On the other hand, they show that it is important GM-CSF, because if you eliminate GM-CSF, but not IL-5 or not IL-3, you decrease the activation of eosinophil, for example, as measured by CD69. So I would like to praise them, and especially Professor Markus Maurer, that unfortunately in a mountain accident passed away last year at the age of 58. So the allergic effector unit looks like you see. The muscle is in a cinematography, send out a pseudopose and attract the eosinophils. And we found by several experiments that this sort of immunological synapse, because it looks like immunological synapse, is quite stable and gives many signals for increase survival of mast cell and eosinophil, not inhibited by dexamethasone, so I like the glucocorticosteroid, but it's not enough sometimes, as we said. And it induces increased muscle activation as measured by mediator release, and also eosinophil activation by phosphorylation of SYK, LACT, and so on. What I want to say is that the main receptor ligands that mediate that we identify as the CD2 family components. On the muscle, the CD48, that is a GPI, that is also found in a soluble form, and on the eosinophils, the 2B4, CD244, that is a SLAM-related molecule that is its own signal transduction. However, yes, already still unpublished, though, already from the beginning, we observe that CD48 is also expressed on eosinophil, but it doesn't participate in the allergic effector unit. And interestingly, if we follow the dynamics of CD48 on eosinophil and on muscle, you see that at the beginning of the reaction, until 24 hours, is quite high. And then it goes down. Very good, because the reaction in vitro with cord blood-derived muscle and eosinophil is an acute reaction that we are trying to mimic. But look what happened already to the inhibitor receptor I didn't talk to you about. The CD300A also goes very up, especially in the activated unit, you see, and goes down. Meaning that as soon as we have an activation, our body, our cells try to decrease, otherwise we would all die. And so don't think it's a temporal fact. First you have activation, then you have inhibition. It goes together, okay? So we have two main ways thinking about muscle mostly, but also why not eosinophil, to stop the allergic inflammatory reaction. One was and is to stop the activating receptor CD48, and the other one you will see by activating one of the inhibitor receptor we found. And why CD48 and not 2B4, for example, you could ask. Because already in 2007, Ariel Muniz, he was my student and now professor at Tel Aviv University, he found that in a mouse model of asthma induced by sensitization with OVA and alum, if you inject a blocking antibody, anti-CD48, you block the appearance of bronchoconstriction and inflammation, but not if you give anti-2B4 of course, an unrelated antibody. You can also see a decrease in IL-5, in IL-13, and in total bulk cells, indicating that is CD48 our target. Moreover, we found CD48 on muscles, but also on eosinophil in human asthma, as you can see here, associated with MBP and with tryptase, MBP for eosinophil, tryptase for muscles, and in the unit of severe asthma and moderate asthma, and in atopic dermatitis, and in nasal polyps. So very good target also in humans. In a study we did in collaboration with Southampton, with Professor Holgate, we also found a very interesting story about the soluble form of CD48 in peripheral blood of asthmatics, that in mild asthmatic, it predicts mild steroid-naive asthma, but in very severe asthmatics, as they take both oral and inhaled steroids, you see it goes down. And at the beginning we thought, well, they take steroids, maybe they inhibit the production and secretion of CD48, but it's not the case. What it is that soluble CD48 we found is a decoy receptor. So the one who has severe asthma, they don't produce it, while the mild still can produce decoy receptor, because if you incubate eosinophil, for example, with soluble CD48, it will decrease activation by 2B4, it will decrease the islate release and the phosphorylation of VAV. This I skip for lack of time. I go to the CD300A, the other alternative. The other alternative we say is inhibit the muscles. Now, I don't know how much you know about inhibitor receptor. I take the example again of Fc epsilon R1 activation. It has, Fc epsilon R1 is a tyrosine kinase receptor with sequences, activating sequences that transduce the activation of the muscles, the release of preformed radiators, the synthesis newly formed by phosphorylation of SYK, lean, and so on, MAP kinases, you see, very regular, you are used to see that. But at the same time, you have an inhibitor receptor that has the receptor tyrosine-based motif that are phosphorylated by the phosphorylate activating receptor, but is upstream. And so you don't have the events at all that cause the muscle activation. And here you can read what you can have if you silence the muscles. And there are already some clinical studies with that. I choose already at the beginning, even if we found other inhibitor receptors, the CD300A, it fascinated me. And I have something also new that I wanted to show, but we don't have the time. Because it's an immunoglobulin like a receptor. It belongs to a family with other 8 members. It has a pair activating receptor, CD300C, that is silent, I can say. And it has a mouse homologue, so we could do mouse studies. And I arrived to that because Moretta from Italy, they were studying it on NK cells that make me sound an alarm. I don't want to hit the NK and to silence the NK. Of course not. If not, we'll treat allergy, but we'll have more cancer. So because of that, you see what we developed. And recognize also, this is fascinating me, phosphatidylserine and phosphatidylethanolamine that are expressed on apoptotic cells and activated cells, things that you see in inflammation. So because of that, it was chosen. This is a history all published a long time ago that we had as a beginning an antibody by the Moretta called anti-RP60, is anti-activating CD300A. But what I want to show you is that by this on muscles, again, cord blood-derived or eosinophil, applying this antibody, we have less activation of muscle as measured by beta-hexane tryptase release, IL-4 release, and eosinophil activated by IL-5 release less of all this mediator and the signal transduction. Is a good target? Yes, it is. We found in humans, in atopic dermatitis, for example, that 150 atopic dermatitis patients in the lesional skin has an enhanced CD300A because it's trying our body to downregulate, less on the non-involved skin and not so much in normal healthy skin, and not only as a messenger RNA level, but also as a protein level associated with eosinophil and associated with muscle, and in a mouse model of atopic dermatitis, atopic in CD300A knockout mice, atopic dermatitis was much more severe than in regular mice. Not a knockout. So, because of the presence of CD300A also on NK, we decided as a time to produce a chemical produced bispecific antibody with one arm against IgE that is always sensitized allergic patients' muscles, and or c-KIT, and CCR3 for eosinophil, and my student Ido Bachelet and Ariel Muniz at the time shows that in vivo and not only in vitro they could stop allergic inflammation. Where are we now? Of course, we're in the era of engineering. of antibodies. We have a cross-mab antibody and now a single-chain antibody. And we could show in vitro, for example, that the masses that are activated by, sensitized by IG and activated by the allergen, olive oil allergen, they decrease the release of tryptase when they are incubated also with the cross-mab antibody. Last but not least, I must show you quickly this slide and the next one, and I'm done with that, is to reverse your concept of the bad guys of the muscle. So here we look at CD300A in the model of allergic peritonitis, again, of albumin, SCB. We follow CD300A, that is a white circles, and you see again it goes up with inflammation, then it goes down on eosinophil, muscle, macrophage. If you do this in knockout mice, you don't have a resolution of inflammations that you should have at 1 for 4 days, mostly because eosinophil remain. But look what we found. We found that if we do an overshoot of muscles, we inject muscles in the mice that are not resolving, my student found, well, not significantly, but you have much less eosinophil, and you have a lot of resolving D1 that is a pro-resolving lipid mediators. And then this is a boom, I think. We are still working in collaboration with Charles Siran at Harvard. We found that muscles, indeed human muscles, and we have the cord blood derived, the nasal polyp, foreskin derived, nasal polyp derived, so primary of tissue, as soon as you activate them by IG and allergy, not only they do the catastrophe of producing and releasing histamine, heparin, and so on, but they produce very high amounts of these resolving D1s, and from the name is a pro-resolving lipid mediators. And this goes on with time, even in the allergic effector unit. This is allergic effector unit. You see a 72 hours muscle in collaboration with eosinophils that do not produce resolving, they are still producing resolving D1. Resolving D1, for example, downregulates PAF activation of eosinophil to release APX, or activation of IG by muscle to release tryptase. Now, why I put this in yellow, I wanted so much to show you the data, but the student, unfortunately, is called in the army, because unfortunately, the situation in Israel, all the story have another side. These are all papers we publish on CD300A, being the one in allergic inflammation, but he wanted to see what happens in cancer. And what he found, and we were quick enough to submit to publication, inhibitory receptor CD300A function and immune checkpoint in a mouse model of breast cancer. You will hear more, hopefully. It will be accepted, hopefully, or if not, we'll do other studies. Now I have 0 minutes, so this is what I wanted to say, that I'm sure we go to the good, especially with the muscles. I don't say to use the summary, I hope you remember, but you will have the slides. What I want to say is, though, I read with you, muscle in allergic inflammation are usually the bad guys starting all the process, but they might become good ones. Eosinophil accompanying muscle is mischief. Main immune cell receptors in this saga of allergic inflammation, but not only allergic inflammation, are the inhibitor receptor CD300A and the activating CD48, especially expressed by muscle and eosinophil. All this, what indicates? It indicates that CD300A and CD48 as pharmacologically targets should be timely and specifically manipulated on these cells also depending on the disease. So what does the president of the Columbia University, Harvard University say? It depends on the context. I don't know if you know what I'm talking about, but I use this. Context is very important, especially in science. Thank you for your attention. I have to put beautiful Jerusalem, my student, you for your attention, my collaborator, and the presents they gave to me, a thermos. It must have been love, must sales. And it is, in a way, 0.